Hello and welcome to Merlins-Maker-Spaces, this time part 3 of our mini tutorial making an apple catcher game. In the last two tutorials we've done our basic background and our player motion. Now that that is done, we are going to add the apples dropping from the top of the screen down to the bottom. We might speed up our basket a little bit. Let's add in here the screen width as maximum speed. Let's see. Okay, so that it will traverse the screen with much faster. Good. Now let's come to the apples. First of all, we've got to create the apple class, which will hold all the necessary information that is related to the apple object. Let's simply call it apple. Create the constructor, and similar to the player, let's pass in a texture, position, a maximum velocity, max vel, so let's capture them in attributes. The texture is equal to texture, self.position equal to position. Let's also put a direction in here. Self.direction equals vector 2 0 0. Self.maximum velocity equals maximum velocity. Okay. And when we think about it, we also want some sort of acceleration effect with our apples coming down from the screen. So let's add a y velocity. Self.y velocity. And for now, let's set it to... No, let's set it to 1. No, wait. Set it to 0, of course. We also now need some sort of acceleration that we increase with each frame. Self.acceleration. Rate, let's call it, which will be added to the y velocity. Which reminds me, we want to randomize it a little bit. So let's add the random module from random import randint. So that is one component of the random module that we will use, and we'll also import uniform, which will give us floating point values randomized. Okay, so acceleration rate, yeah, we'll use uniform in this case. Or not necessarily, we could also use randint. So randint. And then let's see, where do we start? Let's start with 10 pixels per second. Acceleration rate up to, let's say, make it 400. Good. I think for now that does it with our apple constructor. Now let's just make the template for our update method, self, and also in here we add delta time. For now we'll pass draw self and draw texture v. So our vector approach in drawing it. Where we pass in the texture, then the position, self.position, and because we're going by the default color, we pass in white. So in theory that should do it. We could already display it if we had the texture loaded, which we will do right now. So down here in our game_init method, we'll first load the texture. Self dot apple texture, which is going to be in our images folder, apple1.png over here. So let's load that thing. Load texture. It's right in our assets folder. Images and apple_1.png. Good, let's take a look. Let's create a test instance of our apple. Self.apple test equal to apple. Self.apple texture, and let's put it somewhere in the middle of the screen on top. Let's say self.screen width, and y coordinate 0, just right on top. Good. As a maximum velocity, let's just pass in 2 times self.screen height. It doesn't really matter right now because we're not using it yet. But anyways, we can already draw that image just to visualize it. So right here, somewhere below player basket, self.apple test.draw is what we call apple test.draw. Wait a sec, we can't see anything. Of course, it has to be screen width divided by 2 in order to be centered on the screen. And there we go, a very tiny little apple. Perhaps a little too small. I think we could use it, but it would look a bit nicer if we could scale it up a bit. So, let's do exactly that. And use the method we've used before for the background. Let's comment the texture loading out for now. And load an image instead. Self apple image equal to load image. Same path as before. Good. Now that we've loaded the image, we've got to apply the transformation on it. Image, resize next neighbor. And let's double it. We can take a look what the dimensions are. 21 by 20. So let's make it 42 by 40. So 42 by 40. We can leave it as a temporary variable. Okay. And then we'll load the texture as an image from an image. So self.apple texture is equal to load image from texture. Load texture from image, sorry. That should do it. And now if we run this, we should see that the size has doubled. Okay. Very good. Now let's think about making it falling down the screen. So for that, we'll have to go into the respective update method. And let's see. We have to work on our acceleration at first. So once we got our acceleration rate, we'll increase the velocity. So we start out with self.y velocity, and then we'll increase it with each frame. Self.acceleration rate. And of course we've got to multiply it by delta time so that we get a movement per second. Right? So for example, if our acceleration rate is going to be lower bound, the random value lower bound 10, so it's going to basically increase very slowly its velocity by 10 pixels per second, or upper bound 400 per second. Good. Before it works, we have to update the position. Position.y by self.y velocity. Has to be plus equals times delta time. Okay, yes, and also multiply it by self.direction.y. I think normally we would not really need the direction variable here, but just in case, if we want to apply some changing directions, like bouncing off apples, it might be quite useful. But right now, we just want to let it drop down. So in the vector2 function in here, it's gonna be 1 on the y component because we're moving down. So that should actually do it right now, and our apple will drop. I hope. Of course not, because we forgot to implement the update method. Let's put it in here. Self.appleTest.update, pass in delta time. Save it. And yes, you see it's accelerating, getting faster. Okay. Let's give it another try. Slightly faster. And again. Okay. So that's basically working. Now we need to find out how we can do the same thing with a really big bunch of apples. So in order to do that, we'll have to first go into our game class and create an apple list. Self.apple list, an empty one at first. That's where we're gonna store. We're gonna add to our apples. With each apple that spawns is gonna be appended to this list, and also in order to keep things relatively tidy, we'll also create a max apple variable. How many do we want to have on screen at the utmost time? So I'd say 5 is the maximum amount of apples we want to have in our list before things get deleted, right? Good, we got the apple. And we also need a kind of spawning timer for that. So a certain time that passes before an apple is added to the list. So let's call it spawn time. Self.apple last spawn time. And we set this to 0 for now. And then we also need a interval. So meaning the time span between each apple spawn. So let's define it at first. Self.apple spawn interval. Let's make it 2 seconds for now. Oh, let's say, wait. We can randomize it actually. Right from the start, let's make it random. Uniform. For this we use uniform because it's going to be a range between floating point values. So let's start out at 0.5 seconds to maximum of 2.5. Okay, let's make it so. Okay. Good, of course, this changes nothing yet. We still have our test apple in here. And we'll create inside the game another method that will simply spawn the apple. Let's call it apple spawner. And in this thing, first we'll check if the length of the apple list does not exceed 5. So if len self.apple list is less or equal to 5. Should that be right? no, if it is less than 5. So then it still will be capable of spawning more apples. Then we'll say if get time, this gets us the current time in that moment, is greater than the last spawn time, self dot apple last spawn time plus the self dot apple spawn interval then we want to take our list self.appleList. Then we want to append something to that list using the append method, and then we'll add the apple object right in, or more specifically the constructor. This gets the texture and a position, which is a vector 2. Let's call the components rand x and rand y. Which we'll define in a second. Maximum velocity, let's make it 2 times self.screen height. So it caps out somewhere at, one screen is 900 pixels high, so somewhere at 1800. Anyways, rand x is going to be a random value, randint, from 0 between screen and the screen width minus the texture width, so self.apple texture.width. Okay, so now we've accounted for the random x value. Now let's see what the random y is going to be. Rand y is randint. And then let's think about it. We also want to give it a little bit time to accelerate, for example, to position itself, and therefore we'll position it above the screen, so not exactly on top of our what's it called, the viewport, what we can see, but maybe another screen length or height above. Sorry. So we'll be starting out at our negative y value, negative self.screen. That's our topmost value, to almost right on top of the screen. So let's just make it 0. So within that range, our apple object is going to spawn. Okay. Once we got that, we also have to reset the timer. Self.apple last spawn time equal to get time. Okay. Alright, now I'm just checking if there might be any errors, but okay, let's test it. in order to test it, of course, we've got to comment out our test apple. Test.draw. So that it does not interfere with our test. Good. Of course we need, what I forgot, we of course need to update all and each of them. So in that case, update all apples. Self and delta time. For that to occur, we have to loop through the list for apple in self.appleList. And we call apple.update method on each of them. Same thing with drawing. Let's make another custom function, draw all apples. Self is all for apple in self.appleList apple.draw. Good. Let's go and call the apple spawner in the game update method. So down here, self.apple spawner. And down here in the draw method, apple spawner. Okay, we're not done yet. Self.update all apples. Delta time we've got to pass in. And of course, draw everything. Self.draw all apples. Oh, of course, one more thing. I think because we also want to keep randomizing the spawn interval, we simply copy this line here from the constructor and put it into the apple spawner. And then the apples are going to spawn much more randomly, a more staggered approach, much more unpredictable. Let's see if it works. There comes an apple number 1, number 2. Okay. Oh, of course. So after 5 apples have dropped, then of course it stops updating, it stops spawning. So we have to do something against that. Because once the condition is met, as we said in here, the length of the apple exceeds 5, then nothing's going to happen anymore. So we've got to delete them once they reach the bottom of the screen. For that, let's create another attribute, self.active, and set this initially to true. Because when they start from the top of the screen, each apple instance is going to be true. Once we reach a certain height, meaning we exceed the screen height, or even if we collide with a player later on, we will set this self.active attribute, a boolean, back to false, to false. And then of course we can sweep through the list and delete each item that is flagged as not active, right? Good. So for that, let's create another custom function and call it apple despawn. Also no custom arguments, just self. And then we use something that's called list comprehension to work with the list. Self.apple list, like so, square brackets, and then we'll access each apple in the apple list. Apple for apple in self.apple list, and then we've got to check. So while we're looping through each element in the apple list, we will be checking its active value if apple.active. So again, this expression here, which is a list comprehension, is going to return an apple instance only if the corresponding apple flag is set to active. Is set to true, I mean. If apple.active is equal to true, right. That's a shorthand form. I could write something like this is equal to true, but that is redundant. It doesn't need be. Good. So, now that we have that, let's call the apple despawner down in our update method. Self.apple despawner. Let's take a look what happens. We can visualize it, of course. Let's draw it to the screen. Draw text. It's up in the left corner. It's a string. Convert it to a string at first. No, we want the length of the apple list. Positioned at 1010. Whoopsie daisy. Did I forget something? Ah yes, of course. Typical beginner mistake, I always forget to add the color tint. So let's make it green. Give it a matrix green. Right. Also the size. Let's make it 40 pixels high. Let's go. There we go. So now our list is being populated, and as you see, nothing is deleted yet. because we did not implement the code inside the apple update method. So let's get back up. And then we have to put in the condition what's going to happen to our individual apple object if we reach the bottom of the screen. So another if clause in here. If self.position .y is greater than get screen height. Then we want to set self.active to false. So that should already do the trick. Right now our list is being populated by the spawner, and then once, whoops, you can see it, once it reaches the bottom line, it despawns. And so we are getting a continuous loop of spawning and despawning apples, and as you can see, their velocity and their acceleration values are random, as well as the position. So basically, that's our foundation of our apple spawner. Of course, we don't have any collision and no sound effects, no BGM yet. We'll have to add that later. And maybe some extra effects if we have the time and the creativity. There we go. We can also add another check here, self.visible, which will be initially false because we are off screen. And then we might add that in here in our draw method, so that we only draw the texture when it is actually visible and not in a memory location that we cannot see. So if self.visible, only then do we draw this thing. Then we can add another check in here. Self.position.y is either less than 0 or self.position.y is greater than get screen height. In both of these cases, we'll set visible to true. Oh, no. I'm sorry. Let's make it differently. If self.position.y is greater than 0 and self.position.y is at the same time less than get screen height. So again, if it is greater than 0 and at the same time less than the screen height, so right in our viewport, then it's going to be self.visible equals true. Otherwise, self.visible is going to be false. Does that change our behavior we have? Nope, exactly what we wanted. If it is on screen, then we can see our apples dropping. Okay. So for now, we've got our basic structure for dropping apples. We might expand on it later on. So that's for now. I hope you enjoyed and learned a little bit, just as me. And see you at the next one. Have a good one. Bye-bye.